As with DC systems, on multi-engine aircraft, constant frequency AC generators can be operated either in isolation or in parallel. On most two-engine aircraft, the generators operate in isolation, while many aircraft with more than two engines have their AC generators operating in parallel. In this lesson, we will look at parallel generator operation. You will recall that for DC generators to operate in parallel, their output voltages have to be the same. Similarly, the output voltages of all AC generators being paralleled must be the same. However, for three-phase AC machines, things are a little more complicated than that, as frequency and phase sequence also need to be taken into account. If the two generators are at different frequencies before they are connected in parallel, then damage can occur, as one generator tries to slow down and the other tries to speed up, so they must be at the same frequency before paralleling. As well as being at the same frequency, they must also be of the same phase sequence, and in phase. That is to say, at any point in time, phases A, B and C on the first generator must be identical to phases A, B and C on the second generator. If two or more AC generators are connected in parallel, their frequencies will be locked together. The system frequency will be that of the generator with the highest load. You will recall the load on an AC generator, the apparent power, is made up of two components: the real or true power or load, and the reactive power or load. Each generator must take an equal share of both the real and the reactive loads. Load sharing is not required when AC generators are operating independently. Real power is the work being done by the generator in supplying the various resistive electrical services. It is the product of the in-phase current and voltage, and it is measured in watts or kilowatts. Real load is directly related to the mechanical effort or torque required to drive the generator by the engine, through the CSDU. If the torque required to drive each of the generators connected in parallel is equal, then the real load on each generator, or the real power produced by each generator, will be the same. Real load sharing is achieved by controlling the CSDUs and adjusting the torque at their output shafts so that all parallel generators are experiencing the same torque. Each generator has a load controller, which controls the CSDU to maintain the basic frequency of the generator in a range of 380 to 420 Hz. When generators are connected in parallel, each load controller senses the in-phase current being supplied by its generator. The in-phase current is proportional to the real load being supplied by the generator. The load controllers are interconnected, and if there is a difference between the generator real loads, the controller of the generator taking the lower load will signal its CSDU to increase the torque input to its generator, and the load controller of the generator with the higher load will decrease the torque input to its generator, thus ensuring that each generator takes an equal share of the real load. You will recall that reactive power, or the reactive load, is a product of the vector sum of inductive and capacitive currents, which are 90 degrees out of phase with the voltage, and voltage, expressed in kilovolt amperes reactive. A generator's reactive load is therefore directly proportional to its output voltage. Reactive load sharing is achieved by controlling the voltage output of each generator that is connected in parallel, by adjusting the current flow through the voltage regulator to the exciter generator. If the parallel generators' output voltages are identical, then the reactive load on each generator will be the same. Each generator has an error detector, which is monitoring the reactive load being taken by the generator. The error detectors are interlinked. If there is a difference between the parallel generators' reactive loads, then the error detector of the generator with the higher load will signal its voltage regulator to reduce the exciter field current, and thus the generator output voltage, and the error detector of the generator with the lower load will signal its voltage regulator to increase the exciter field current, and thus its generator output voltage. That is the end of the lesson. Here are the main points that you need to remember. The output voltage of all generators being paralleled must be the same. The frequency of all generators being paralleled must be the same. The phase sequence of all generators being paralleled must be the same, and they must be in phase with each other. Real load sharing is achieved by controlling the CSDUs and adjusting the torque at their output shafts, so that all parallel generators are experiencing the same torque. Reactive load sharing is achieved by controlling the voltage output of each generator that is connected in parallel, by adjusting the current flow through the voltage regulator to the exciter generator.